vector analysis. Vector analysis. And in vector analysis, as it were, we have the grad operator, which is the vector operator. Now we have what we call the grad phi. Grad phi is nabla of phi. And nabla phi is equal to I direction, partial respect x, plus j direction, partial respect y, plus k direction, partial respect z. Now, this is referred to as grad operator, which is also called the gradient operator, which is also called the vector operator, which is called the nabla function, So by the time we have this, and phi is equal to a function. For example, phi is a function of three variables, x, y, z. And this is equal to x squared plus y cubed plus z itself. So if this is phi, and we are to find, they now say, okay, if this is equal to this, find grad phi. Grad phi that you are expected to get, solution to this, will reflect the grad as nabla, which is the gradient of phi. Gradient phi is equal to, now, I directional vector partializing with respect to x plus j directional vector partializing with respect to y plus k directional vector partializing with respect to z multiplied with the entity given as our phi. And the entity phi, of course, that was given above will be there to be x squared plus y cubed plus z. Take notes. Take note of this. Now, when we partialize directly, we open the bracket. In partial derivative with respect to x, we are going to recognize x squared. And if x squared is differentiated, we will now be having 2x I directional derivative plus partializing y, because there is no y function. Partialize y with respect to y, you'll be having 3y squared j directional cap. Plus partializing z, you now have 1, and that is going to give you k cap direction. Take note that it is a vector quantity. The grad operator is a vector quantity. The grad operator is a vector quantity. So if we are given point, find this at, for example, now get the value at points of 1, 0, 2. For example, what this implies is that x value is equal to 1, y value is equal to 0, z value is equal to 2. These values will be inserted in already differentiable form, so that phi, nabla phi is equal to 2xi directional derivative 3y squared j cap plus k caret. They all mean the same thing. Now, by virtue of this design, we're going to insert the value of x, which is 1, here to give you 2 times 1. I direction plus 3 multiplied by 0 squared. J direction plus k direction, because there is no variable attached to k, so no substitute to be there. So of course, the z substitute is valueless. So when this is summed together, you'll be having 2i directional vector plus k directional vector. At the end of the day, this is the resolution of the grad operator or the vector operator in vector analysis.